So hello everyone. I want to have a small little gauge of who we are here. So who's coming from IT or IT related world or field in their daily job? Raise your hands. Okay, so almost everyone. Who here is more on the developer side of things, like actually writing code day to day or at least time to time? Okay, great. And who is somewhere in between these two? Who didn't raise the hands? Okay, hopefully after today you move more towards the other thing. Or the other way around, I guess. Okay, so hi, I'm Muntis. I'll have a presentation about what I would call like vibe coding is the cool name nowadays. Vibe coding for production. What do I mean with that is there are plenty of AI agent platforms coming out almost week to week, or some sort of a tools or significant updates and all of that. And all of that is super exciting and interesting, but the moment you start to look at it from the lens of more, let's say, serious or boring enterprise development side of things, it's not as simple as it might be, or not as great as it might look at the first glance. And I'll talk about our experience with it, how we've adapted some of that, and actually where I think the industry is going to go. At least there are strong signs of that. So I'm Muntis. I'm a data scientist by trade, but I'm very close. My typical, let's say, task in the things I do in day to day is actually figuring out if some sort of solutions. It used to be data science, then it was or data mining, then it was ML. Now AI is the buzzword of things, or agents. But essentially trying to figure out how these new exciting technologies fit into either existing or new products. What's their actual perspective, how feasible things are. So a lot about experimentation, rapid prototyping for new tool development or new product development. The presentation already is available in my LinkedIn if you want to check. I'll have another QR code at the very end. Because I prepared this talk for a conference in Porto a couple of weeks ago. So it's a lot of the same, but a little bit different flavor this time around. So yeah, I haven't added the latest programming language here, so I have a couple of these ones. Who knows who's probably the most popular programming language today? English. It's English. So that's what we're going to talk about today. Vibe coding, what does it mean? About main platforms, and then the interesting part for me is how we can structurally look at this thing and what is our experience with that. So what is vibe coding? For those who don't know, the origin is a unlucky tweet by Andrej Karpathy. For those who don't know, he's one of the original kind of founder team of the OpenAI, and he worked at Tesla before, and he's a scientist high level about the LLM architecture and all of that sort of things. And he made a tweet saying that, well, lately these LLM-driven AI coding tools are getting so good that you can ask it to do a thing, and without saying like edit code, make this function, create this object or whatever, you can say it, create a feature. So on like a higher level, and they get it right more than half of the time. So it's pretty great for quick tools like to do something, and it's especially great for things that you can toss out, or it's your small helper script or small tool or internal use or your personal use. So it's disposable, I would say, right? It's quickly to recreate as well. And if you look at it from a bit more serious perspective, so you can look at vibe coding as an abstraction layer. So these LLMs that you talk to probably daily, to like ChatGPTs, Geminis, Grok, or whatever platform you use, Claude. The concept is essentially to use that as an abstraction layer, because a lot of the known concepts or approaches for the coding are publicly known. There's plenty of books and plenty of GitHub that all of these companies have scraped to use. And the concept is giving larger and larger tasks on more kind of human understanding level, because for a lot of commodity tasks, these are known solutions. You need to add a button that opens a side panel that's been done thousands of times, So LLMs probably know how to do it quite well. And for vibe coding, so giving larger tasks, doing little or no reviewing, this is typically a part of these platforms as well. If developers are very feel very strong ownership of the code, and this sometimes is a little bit difficult. And yeah, disposable outcome, and at least initially the concept was more for proof of concepts rather than in generally. But as we will see in a moment, that's a little bit unfortunate because now we have more than 10 serious players as a big platforms or tools that play in this space, which I would call is agentic coding, because you have your LLM agent who interacts with code, kind of in between you and the code directly. And we have plenty of tools coming out, and I would like to put them kind of on a scale. So there are coding tools, GitHub Copilot, Cursor, Windsurf, Google's Anti-Gravity, which came out a couple of days, which is a VS Code fork, right? That are more developer intended, so adding more power to the developer, or enable him or make him 10x or minus 10x developer. And then there are more platforms who are kind of on this higher level, so you just prompt it and it magically knows how to write the code to actually provide you with the platform. And at the far spectrum, I added the level platform, which is, I would say, and which I have first-hand experience, it's very intended for kind of more entrepreneur product style of person who has some vision about product. It's really great to create some initial product or try out different ideas or different approaches, discard them, try again. So it's very cheap and easy to retry. It used to be expensive, now it's less expensive from that perspective. And I wasn't sure if I should include a little bit of technical demo or not about this. So who has tried some of these kind of more on the platform side of things? So Vercel, V0, Lovable, anyone? Okay, pretty good. But in very short, in a couple of slides, so what is this platform? If you know ChatGPT or something similar, it kind of looks like that. You have this prompt window, so all of that's common from these platforms is they start with a prompt window, right? But how it continues afterwards is you essentially have this chat on the side, and you prompt things, and you ask things like, create me an app that's like an onboarding thing that has like a process to help users get accustomed to their job responsibilities based on the role, add like an admin panel to show process, all of that you kind of describe as a, you could call it a feature description or user story or something like that. And then it magically appears after a couple of minutes as a made website, and it's automatically hosted, and it has an actual database behind the scenes, and it's actual code rather than a slide or an image. You can extract the code or connect it to your GitHub and continue working out as a developer. So it's kind of amazing what you can do in a quick way. And it is instructed in a smart way to use the tools and the platform that it's using, like in Lovable case, that's a React application with like a SOAP-based backend and database. You can create initial version and then continue developing, or you can continue working this way, and it works fairly well. There are a lot of caveats, which I'll talk in a second, but it's quite interesting how much you can do, and this will only get kind of better. The big question is how good it will get eventually. So a couple of more pictures from the same platform. There is a recording online. Emergn does like this technology morning thing a couple of weeks ago, where I walked through 10 or so prompts where I created this small onboarding tool. This is actually like the admin dashboard of different people going through these kind of onboarding learning steps, and here you can see a bit more, like a stepper at the top, and then during the demo I actually asked the platform to, okay, add the stepper on the side so we can like skip steps or add things like that. And then at the end, this is kind of sent to the background, but I asked the platform to, okay, can we also have like an AI chat that's a part of every platform? If you haven't seen this icon, like this diamond thing is on most tools nowadays, unfortunately, which will open some sort of an AI assistant, because that's the because who doesn't need an AI assistant nowadays? Okay, but that's how it looks like. It's pretty great. It's pretty easy. It's almost scary how good it is. So in a couple of years, you're gonna see people with professions like fixing vibe-coded applications or refactoring them and all of that. Because what's happening behind the scenes, it's a little bit of hit or miss. And this is very important decision on how you develop this. Whether you plan this as a prototype, a design piece where you can try out different things and toss it out potentially, or you plan to actually continue on this on kind of more serious development. And this you kind of have to realize quite early on, and we'll talk about that in our approach. So yeah, the dream is create an app in few prompts over a weekend or a week, get money, quit job, right? That's it, work prompting one hour a day or something. So at first it's amazing, especially for UI. My personal preferences for these elements, it's actually pretty good. But you start running into issues, and especially in these platforms that you don't really, if you don't really follow what's happening in the code, you will accumulate debt. And how you should take debt and how you should look at this is that if a team of, let's say, 2 or 3 people are able to create the amount of code that normally, let's say, 20 people would do, a lot of the maintenance and depth and chore style of tasks are of the amount of 20 people. So at some point you run into a stall and the velocity drops and the code base gets big enough so that LLM gets confused and it doesn't figure out things on its own, but hey, it's easy, let's generate a new version of this. And you end up having a platform that's coded as 100 students who each has a slightly different interpretation on good practices. Let's put it like that. And I've been more student than I haven't been, so that's coming from first-hand experience. And if you actually look at these platforms, they typically have some sort of a launched site or referral links or whatever, which they show people who actively said, okay, we developed this in this platform. And it's pretty interesting to look at these. And what you will notice if you go through these lists, most of their apps are very simple one-purpose applications. To-do apps, focus apps, some tool that does one thing quite well. This is great, right? This is nothing wrong with it. Mobile apps, for example, typically it's fine if they are simple. But most of the more complex apps, if you follow the communities, they migrate to what I would call full code. That used to be just code, but now I have to say full code eventually. Because how you can look at these platforms is, there was a thing a few years ago about low-code, no-code platforms, which help to develop fast some things. But developers typically are a bit skeptical of those because at some point you want to fine-tune some things and then you're locked in this vendor-provided features and it's not great. This is kind of a bit better, right? Because you can prompt everything, but if you really need to, you can go into the code and actually have a full changes of the code, right? So what's the gap between this and developing large websites, for example, on the practice? And before we get there, a quick kind of recap of what I think works out of the box of these platforms and where it's great, and what really doesn't work too well. So I generally think that for the exploration of, let's say, trying out a new product to see if you have a good market fit for your product, to vibe code an app and go to people and show it and see if they actually want to use it, and then kind of dig into the deeper development, this is amazing. You used to make slides or wireframes, then you used to make Figma with clickable prototypes. I think this is the future now for these sort of things. It's great to what I call one-shot multiple variants. So what I've done in the past, I've developed a couple of internal apps with some of these platforms. You create a description of what you want to make. You can open 3 windows of the platform and paste it in each of those. And maybe in one you say, just add one sentence, like I would say description, like a 3 paragraphs long, what the platform needs to do. And you add like one sentence, okay, this is for, I don't know, technical developer. or this is for kids, right? There is a lot of inherent thinking in what an application for a kid might look like, or what an application for an enterprise developer look like, or what an application for a business analyst might look like, right? We intuitively know this will have big buttons, colorful things, this will have drop-downs with a bunch of options, this will have something else. And this is what's sometimes missing from the requirements, right? So it's great for those. So it's great for MEPs to get to an early prototype which you can show. It's great that this is a full package for solo development or solo entrepreneurship, because you open the platform and you prompt. No Dockers, code editors, authentications, complex for connecting to other platforms. It's kind of batteries included. While you're in the platform, some workflow or UX changes that would be very difficult in standard coding, which would be like a big refactor of a lot of the same thing, work surprisingly well in this platform. Let's say, do you want a pop-up window or a sidebar for your AI assistant because you must have it in your platform, right? You can try out both variants and check which one works better. Previously, you would spend probably some time on design to implement it and maybe be only 80% happy at the end. Modular applications, what I would call flat and wide applications, right? So like a dashboard with 100 buttons where each does a thing, but there is very little interconnection between the processes, right? These work quite well because small module, small context is great for LLMs. And visual and typical CRUD operations. So if you want to develop, let's say, some UI elements, you will vibe code them, you will immediately visually see if they are as you want them to be or not. So that's a first level of test, right? If there's a backend function and you vibe code something, unless you write tests or check a bunch of outputs, you don't really know if it works how you expect it to be. But for visual things, this is great. What maybe doesn't work that well if you played around with these platforms a bit. Large edits with huge huge minimized code, interesting. Large edits that would refactor, so you might want to add a small feature, but because of how application is built, this is actually a large change because of architecture decisions. It really struggles to do these things because it's good at following what's already there rather than doing large edits in general. And yeah, guessing when to do like bigger refactors based on this, developers would say, okay, we need to change internally a bunch of things, and then only in a month we can start working on the actual feature. Well, in the prompt you would ask to do the feature, and you wouldn't know why it's struggling for so long and you're getting errors. Other setbacks for these platforms, there's very weak collaboration options in a lot of them. For the more developer-oriented ones, it's still the same, you use Git and everything great, but for the Lovable, for example, it's one person, right? You can work in shifts or something, or prepare prompts in your pocket while you get your turn, right? But it's one code base where it's working on, and I bet they will have a feature in a few months. Surgical edits with minimal impact. Since it's very easy to generate code, the AI is naturally more incentivized. Okay, this doesn't work. Let's rewrite in a way that I know it works. But you might introduce 10 other bugs in kind of unrelated things, and this happens quite a lot. The complexity of modules or separation of concerns is a big thing as well. And if your code base is big enough, you will end up with things where AI missed that you already have similar functionality and you should follow good patterns and reuse, blah, 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 right? It's very easy to generate a new function for the same thing that you have in three places in your application already, right? Because tokens are cheap. And yeah, invisible or complex object, invisible meaning you cannot literally visually validate if it's correct or not. But okay, so that's in very short about the good or bad. Here I have a list of practices on what to do or not to do in relationship to these platforms and where I think these coding tools will go in a couple of years' time, or in a year's time, I guess. So first of all, and they kind of go in the order of complexity a little bit. So the first one, prompt quality still matters, right? prompt engineering, even prompt frameworks like Clear and all of that used to be a thing in like 2, 3 years ago when the LLMs really hit the market. It was, okay, they are really sensitive on how you ask them things. So if you follow specific structure and now you do this and start with you are blah 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 expert, right? This used to work better than if you didn't do that. Now it's a bit different. The new buzzword is not prompt engineering, but it's probably context engineering, and it's more about how you actually provide all the details and specification to the plan and how you think about it. Because as I started with, the LLMs are quite good at picking up random details. So let's say you have your product description, but then you have this reference similar tool that somewhat overlaps with your product. Or you have this other platform, or you have your user persona description. This is not a requirement for the product, but it is a valuable context. So you might just throw everything at it, right? And other parts as well. All these platforms have some sort of a tips and tricks or how to do or do not or not to do things as well. Some are platform specific. Meta prompting is a thing you should really try. So this is, okay, I have this tool description, ChatGPT or Gemini or whatever, create me a prompt for a lovable platform that will create me an application that does this, and it will come up with this structured plan, and then you go in and validate it and actually read it rather than just copy paste it because it's so easy, and you will have a way more robust description of what you want to do, which you will edit as well. So kind of prompt to get a prompt is what I call meta prompting. And zero shot and few shot approaches, which I already a little bit mentioned. These platforms are great at doing things at the very kind of beginning, or doing large things at the start. So trying out different things and reverting is a function of most of them, and it's quite nice to revert and redo rather than try to edit, because as I said, generally editing is more difficult than adding things. The next kind of complexity or thing on how to make these platforms work a little bit better. Product requirements document. Very boring name. I'm not sure why this is the term that this goes on by, because we think of this as the large waterfall documentation, where whoever learned about that at school, which I would just call high level a vision document. So you should have some sort of a 2-page document if you are trying to build a tool where you are very clear on what you want to do, what is your user base, what are your main features. You can find the structure for this online. This is not a requirements documentation in its full extent. This is a couple-page document that describes your high-level thinking of what the product should be. And you will start with this to say the platform use this document to create the tool, right, and provide it, and it has most of the details there. And this will work as a persistent memory for your AI. It will always be, so this was the inherit knowledge example that I mentioned before. If your app is for kids or if your app is for business professionals, it has a lot of inherent meaning that you might not explicitly say on how to add the button, but it means a thing for it. So this is great, and it will work as a persistent in the background. You always have it. It's in your repository, created as a Markdown file, typically somewhere. Most of the tools look at these files automatically if you put them in a specific way. So this will be the kind of the high level description. The next part is kind of a README for AI agents. There is a notion now, every big tool, Claude, Gemini, Cursor, they create their own some sort of a memory or tips on how to interact with the platform. There is a notion, okay, let's move all of this mess into Agentic. What is Agentic? So this is Markdown file, so this is what developers have in the README files. You have a similar one like that, but this is which has probably a bit more on the actual kind of practical what command to run or which pattern to use things. It's quite similar to that, but it will have some extra instructions about the environments or how to run things, because these tools can execute things for you if you ask them in English programming language, right? And so forth. And you have to keep these updated because it's always there in the background. You start a new session, your LLM's brain got fried, right? So it forgot everything you were talking to it. And this is generally reusable between, let's say, different developers using different tools. So it's a good practice to have. And you can have many of these files. You can have your module, your backend module, database functionality, add a markdown there with database schema, add a markdown for the UI on how to use your design components or what to not use explicitly if you have some restraints or something like that, right? There are other tools. This is just very, very simple, right? I'm not going to go into MCPs and whatnot today. And then there's one more level to this, where I think a lot of this is going. So, well, before I forgot to mention the last bit. And if the previous bit worked as a persistent memory for your agent or coding tool, this works as a persistent instruction on how to do things. So if you ask your LLM to write the tests for you for the 5th time and it keeps using the wrong library or mocking up things you shouldn't mock up or whatever, you should add that to the instruction file, to the agent file, and it should work better. So this is a persistent instruction that's always there in the background. And then there's one more level, which is just now advancing. Anyone knows any of this? No? Yes? No? Oh, some people have tried out and played out. I will happily talk with you afterwards. I am very interested in this topic. But in general, there's a methodology actually that's around for more than 20 to 30 years, which is test-driven development and specification-driven development. What this is that you have a specification that's very detailed, that works on the level of this is de facto source of truth. You can maybe implement some things in a couple different ways, but this is exactly how it should be. And people have figured out a structured workflow on how to break down features or whole products to the specification level with the LLMs, and then you can use that as your source of truth, and then the code is actually a side effect of that. So you have your whole application described on specification level, and technically you can regenerate app every day and it should be the same. So that's on the level of specification as it should be. There are a bunch of tools. GitHub came up 2 months ago, I think, with the spec kit, which is something that they use internally, I believe, which I have some first-hand experience. Kiro by AWS has some internal workflows like that as well. I haven't tried OpenSpec, and SpecKit has forks as well. But what's generally common for all of these is that you will actually start with what we had in the previous slide, some sort of a vision or product requirement on high level. SpecKit calls this constitution, where you will write what you're trying to do or what you're trying to build. And then you will go kind of feature by feature and write specifications. And these platforms or these tools, they offer a feedback loop where you write a specification and then you make to do a plan, and for the things that are not certain, it will ask you back, okay, so how should I do this, or should I use this or that library, or how to implement this, or do we have limitations for tech stack? So it's a bit more back and forth. And this is great because some things LLMs are good at picking up, and some things they're not good at picking up, so giving them the ability to explicitly ask rather than hallucinate right away is a very good improvement. But all of them follow this basic architecture steps: specification on high level, architecture and plan for the implementation, so they actually separate these two things. Your business analyst can do a specification part, right? Architecture plan and then tasks and implementation and then you get to the tasks level, and the tasks are typically should be small enough or easy enough that LLM can actually, you can code them yourself, but LLM should be able to very easily do them on its own as well. So this will work as a persistent specification these tools have internal workflows on how to cross-reference and make sure that everything's all right. So if you're developing your 10th feature, it will say, well, this is against the specification of the second feature, and you'll have to figure out how to make it compliant, because we all know that everyone's interpretation of truth or how to understand user story can get pretty different from time to time, or even more so from developer to developer. So this is kind of the more complex level. And most of these platforms actually have some sort of an architect or plan mode in them already. So I think that's just the proof that this workflow kind of works. And to be honest, the ability to break down tasks to small levels is one of the cornerstones of human intelligence. So it kind of makes sense to do it this way, right? So we tried some of these platforms, and for some internal development and for some platforms on our own, and we've come up with what we would call our company's AI-first approach, with some easy and some not so easy learnings, which I would put it in steps like this. And here I try to reference the tools from the methodologies that we did before. So first of all, we're talking probably about like a new product development. First of all, you need, let's say, your client or person that you're trying to build tool with or for, and you need to agree and talk through this product requirements documentation, so this vision document on what exactly you want to do. Because what you'll see, like, people have a bunch of interesting ideas, but then when you start to talk about, well, what's the market for this feature, or who would be your end users, and it turns out it's a very niche thing. So that's just a general good practice. And right after you kind of have that general first idea, what's different, you would normally have like a design phase now, but now it's already a functional prototyping. Well, why? Because you can feed your product requirements documentation into the platform and get a result in 5 minutes or 5 hours if you want to prompt it step by step. And this is iterative process where you would get to the point where you think that your platform is how you would want to be. Most likely midway through you will realize, well, this is actually a bad way of how to do this. It should be a chatbot, or it should be a platform with tools, or it should have been a mobile app, right? You will come to the conclusions which you wouldn't know if you didn't try out to click it and actually use it yourself, right? And then we have what I would call like a decision checkpoint, where you have to essentially make a choice. So you've worked with the platform, maybe spent like a couple of weeks or a month of getting the idea of the product. And if your product lives, so you have your market fit and demand for it, you have to make a decision, okay, let's continue with actually developing it fully as a platform. And then you have more or less, in my opinion, 2 routes at the moment, where one is you toss everything out and use the first version as a specification or description of how things should be. That's very fast, right? If you need to develop from the scratch, but you have on the second screen your semi-broken app, it's very easy to make it the second time around, right? Especially with these AI-powered tools. But do it correct this time around. Or depending on the quality of the platform or who was originally prompting it, you can actually continue with that as well. So you have kind of 2 ways to continue that. You have to make a decision, do you toss everything out, or do you continue on working with it? And you can still continue working on the same platform, lovable in this picture, but it can be any of them. Or you continue more with, let's say, a full code tools, whether these are AI-powered tools or something like that. Doesn't really matter, but you have to figure out. And what's easy to do, it's easy to invest too much in this step, and then kind of, what's the saying, throwing good money after bad, right? You started off kind of slightly wrong, but it's kind of working 90%. Well, what's the last 10%? Everyone knows the Pareto rule, right? 80-20. The last percents will be way more difficult than the first ones if your first ones were wrong. Let's just take that. So in general, what we've done is, for example, in my daily work, we switched to full code tools. So we have validated and already have some prototype that we can show our clients, and afterwards we figure out we need to stabilize, we need to harden the application. A lot of these vibe-coded tools or platforms will have security issues or some complex features that you tried to implement but didn't end up implementing, so there might be some leftover code, things like that. And this is the moment where you have to follow the kind of more product development life cycle, but all of your previous things, well, as I said before, you have 3 people coding the amount of 20 people maybe. So all of your guardrails, automation, testing, CI/CD, DevOps, whatever sort of things have to be at the level of 20 people, and they will consistently have to be at that level because your application is just that big, right? And this has a lot of implications, and non-developers sometimes don't fully understand it, but you can get to the point where you're investing more in DevOps things than actually developing new features very, very, very easy. And afterwards, I don't think it's too much different from just following kind of regular software development lifecycle, thinking about agile development here. Iterative changes, doing refactors as a dedicated thing, things like that. And what's kind of our experience on now building 2 or 3 applications for me? One bigger and a couple of smaller internal things. Is that we think that the hybrid development approach, rather than using one of these platforms, it's better. We switched to, in let's say, project to have some sort of a feature complexity estimation. So let's say you have a platform, someone's using Lovable as a platform, and the developer is using Cursor, VS Code, whatever, to actually edit the code. And you can edit the code and Lovable picks up that you pushed something to the repository, right? So low complexity features, or these visually testable things like adding new things. Very easy for these AI platforms to do. I prefer to do it that way. Crude things like create, read, update, delete, typical operations of things, very easy for the platforms to do. High complexity logic, it's preferable to do that in full code, right? Because if you're having to reprompt to do a thing, it's probably complex enough that the AI will struggle with it, and you need to look at the code a lot. So yeah, that's about the feature complexity thing. And then there are a bunch of process adaptations. So this is in contrast to, let's say, more standard agile development. So for the features or things that are kind of more given or easy to understand, you just implement, right? You don't really do too much planning or too much description. Like everyone knows how a dropdown should work, like even more complex dropdown with movable tags and things, right? So a lot of users have high expectations, everyone's used to high fidelity apps. Right? Some things higher complexity things, you move more towards kind of standard development where you have actual user stories of functionality. But the difference here is that for these platforms you would prepare them as a prompt. So you would have a story that instead of maybe being typical format, it would be written as a prompt. And here you can have a discussion with the team where you actually implement a bit more technical, sorry, not implement, you discuss a bit more technical details about it. And once you're happy with it, you're kind of doing a peer review, right? Then you go to these platforms or tools to implement them. You can experiment with starting with database structure first, or having an API description on how things work, like an open API JSON in your platform or something like that as well. It's kind of similar to how people used to have UI user stories, or user stories that split into the UI task and backend task, right? It's the same sort of thinking, that maybe starting with one gives a good information for the other one on how it should work. And AIs are asymmetrically good at one and not so good at the other one. Using AI for your UI elements and then intentionally mocking backend, my best experience here, worked the best. starting with the backend first, mixed luck for me. And code reviews start to get more and more kind of per module than per pull request. What I mean by this is, if you have pull requests into thousands and thousands of lines of code, it's unrealistic to really do any reviews of them, right? So what you end up doing is, once you full code touch to a thing, you go through more in them. So you need a dedicated actual time to spend on validate the correctness and then the structure of the code and things like that. Otherwise, it's just not really feasible. And documenting the things that you're working on, ask your AI to describe the current documentation, put it in the agents MD file, put it in the module directory. Works really great. And there's also some collaboration shift between teammates if we're working with these platforms. People, well, developers, I would say, hate dailies, but people love communication in dailies, right? So you talk through a lot of things on how to do things, you make decisions on the spot, and everyone's in sync and people know how to do things. If you don't have your transcribe enabled in your whatever meeting platform you're using, you might not convey the decisions you made in any documented format. You maybe didn't update the ticket about the technical decision you made during the discussion. You might not have it written down at all. So any sort of transcripts, summaries are pretty good. That was me, right? Yeah, sorry. Are great for the AI as well. So you should think of these platforms a little bit as a teammate, as frequently as it sounds. And even pair prompting, so kind of what I said before, doing discussions with team on how to do things, it's pretty good. And you should in generally treat AI like a junior developer, and this is not a bad thing, or junior developer or 10. And what this means is that if you describe on how to build a thing, and you gave it to junior developers, if you don't provide a clear, detailed instruction, there might be a lot of open up for different ways of interpreting the features and things, right? And you have to keep in mind that generating code is really quickly, so if you didn't do this right away, you will have your 3,000 lines of code created in a way that doesn't follow a pattern or isn't to your liking or doesn't fit the other parts of the system, even if it works completely fine. And so that's a thing to keep in mind. And yeah, learning more advanced Git usage, very useful. Rebase will be your top thing that you will do, not push pull anymore. At least I had to upskill a little bit from how I do things as well. Cherry picking, rebasing will be the thing you do every day. So where I think all of this is going, I think this smarter tooling will lead to smarter instructions, will lead to better code. Keep in mind that the same ChatGPT or Gemini or Grok or whatever you're using, you're talking to is the same on editing your code, but it's agent. What does it mean if it's agent? It has the ability to run files, edit files, create files, so it has the ability to do things. So as these models improve, and as these tools improve, because the smartness in tools like Copilot or Cursor or Windsurf is not the LLM. You can switch the LLM with like 3 or 2 button clicks, right? You drop down the agent and you switch to the Gemini Pro 3.0, which came out a couple of days ago, right? The smarter tooling is the thing that will bring this forward, right? As I mentioned, most of the platforms have some sort of an architect or implement node, which will lead developers to creating a plan, validate it actually, and only then implement it, rather than asking for AI to do the thing and then having to deal with the results. So vibe coding will become more of as a glue, right? You have this plan on how to do things, and then you do every individual bit either manually or through these vibe coding platforms. So it works pretty good. Learning what's good and good architecture and patterns is probably more important than it was ever, right? Because you might not write code character by character, but you will have to instruct to build things in specific way or refactor in specific way because this pattern is better for scaling or performance or just fits the framework you're using better. So developers will shift more about rather than just building, but it will be more on just building by prompting. I mean, it will be more building with guardrails. What this means is that if you have these specifications set or you have these instructions on your project level on how to do things, like think about having a new colleague in your team. You will spend hours and hours with him probably in calls and saying, well, this kind of works, but we do it this way in this project. Put all of that down in descriptions. LLMs are great at picking those up. So, frameworks will end up, I think, having a specialized AI variants. I think if you will open a framework in the framework page, I don't know, React, Vue.js or something like that, web frameworks you're talking about, you will have, okay, open this project in Lovable or Bolt or whatever, and they will have AI variants, and by AI here I mean like your prompt window, your chat, that's specialized to excel in this particular environment, because who else will know how to best use a framework than the developers, and the developers of the such framework, they can write documentation for humans, or they can write a documentation or instruction for LLMs, right? So the LLMs will end up writing more React code than you because you come from, I don't know, a different framework, or from Python like me. And the agentic tooling is way more important than the LLM provider, right? Because everyone's probably seen this meme. Every month or so, there's a new state-of-the-art 2% better than the other one model coming out. We are probably near to plateauing a little bit here, but the tools get better even if the development of large language modules will stop today. The tools will get better, and we will be able to do more. And experienced developers benefit the most currently. So people who are specialized in one area but have experience on being wide. People used to use the term T-shaped developers some time ago, that know what good looks like and has experience, especially delegating other colleagues or splitting up tasks. As you see, these things are very relevant in the AI coding world as well. Quality is oftentimes linked to local good patterns. So if your code base started off bad, it will continue being bad. If you caught up and ask your AI 5 times to refactor until it's good, and every time it spit out 500 lines of code or whatever, the next time it generates, it will look at the code next to it, and it's higher likeliness that it will be correct. Right? So it has a lot of inertia in this way. The architecture flow is a bit different, right? Probably people think about architecture and do this already, but if the old way was to have Google some things and then discuss them with the team and then have a feedback loop about that and then move to implementation, well then now you probably don't start Googling or don't start talking with the team. You ask ChatGPT or similar platform to do the thing. You might already ask it for 5 different options or 2 different options, have pros and cons for both, pick the best one, and only then do like actual human peer review. And this is already like one more feedback loop in, because you started with discussing things with AI rather than Googling your own, for example. And then there's kind of the last bit, which I think is super important, and I think people look at AI-generated code the wrong way a little bit. So there is a lot of ownership shift, and developers are oftentimes quite sensitive or have a high sense of ownership about their code. So let's say you developed a feature, you worked on it for a week, and then on Thursday evening you realize, well, it kind of works and it's pretty great, but if I redid all of it this other way, it might have been a bit better. And you used to either have to spend 1 more week on that, or have to be fine with that. Well, maybe this is only 90% good. I don't know. The performance isn't great. Should have used a different library, but you already kind of quite far in. Now redoing and experimenting with different approaches is comparatively cheap. So code is more of a commodity. So redoing a whole feature or doing a bit bigger feature or doing a bit more of refactor is easier than it used to be. So changes start to get bigger and bigger. And you should generally have a bit less attachment to code to this level. You should think of your AI code, okay, you asked, you got the code. Now go through it, do a critical review as you might do to the colleague that you don't like as much. Right? You would comment on every little thing and nitpick about everything. And the good thing is that you might nitpick your colleague about, well, the variable names are kind of bad, or something like that. Well, for the AI, you don't have to be nice to it. Right? You can just ask it to refactor everything, rename everything, redo everything, and it's quite easy. So you should be more critical because it's easy to do these changes, right? And the initial versions of features are bigger and bigger, right? You might have previously added a quick thing to have a field and then some backend logic. Well, now more of design, more of implementation, more of the guardrails, front-end validation, back-end validation are easy to add, right? These kind of boilerplate things that everyone knows or wants to do, but don't have time for it. So all the bells and whistles of the features will generally be more and more involved into this. And all of this will lead into some shift in agile software development cycle because the time spent is now changing. The steps are the same, but what takes what amount of total time will be slightly different, and will take some time for this to be. And yeah, the most popular programming language will be English, probably for some years now. So it's a good time to get into the coding, especially you start with actually learning the structure and how to do things correctly. And that's it for me. Thanks everyone. Do we have a moment for questions? I don't know.
Yes, we have.
Question on the back.
Thank you for the presentation. I have a short take or question on the ownership part, but from a different perspective. So you and your team, your colleagues were working on let's say, a bunch of features. I have a question. Is there anyone, a human being, who understands the entire solution, who is able to address specific technical questions? And the most interesting part of the question is, how did you achieve that?
Great question. It's a learning process, let's call it like that. So the question is, does anyone really knows everything that happens in the code and what are the high-level patterns? And here actually AI is one of the things that helps a lot as well. So the things that I mentioned, asking to write down architecture patterns or how specific things work and having as part of your code in a repository as this agents file or whatever file you're using really. Or you can do that in Confluence, Jira or whatever you're using and just put it into the LLM every time. It's just a bit less convenient. Really helps because it's a valid statement. You essentially have to look at these code bases to some level as a similarity. Okay, you're bringing up, you're getting pulled into a new project or a legacy project, and you have a code base that you don't know, and it maybe doesn't have documentation. Well, with vibe coding, it's kind of like that all the time, a little bit. So discussing architecture up front, having it documented down, and actually updating the documentation, you can use AI for that. Is quite good things to keep in mind because this really helped us. And over time, you will get ownership of things, but on kind of more architectural level of thinking rather than code level of thinking, if you get what I mean. I hope I answered the question.
Yes, thank you.
Anyone else?
Personally, what has been your greatest insight about AI?
Oh, that's a very on what exactly you mean? These platforms?
Like I don't know, AI is going to take all our jobs, or AI is overhyped, or something like that.
I saw a great comment about this, or screenshot of a tweet, as most platforms do nowadays, which was about, so the insight is essentially like this: for AI to take over the developer world, right, because there's this fear-mongering of developers getting laid off because AI will do the work, right? The users will have to be able to write down the documentation of the things. And they cannot do it now in one way, and they will not be able to do the same for the AI. So I think AI will become a very powerful tool, but that's a tool for developer rather than an auto-magical thing that does a thing for someone else. So that's my take, is that we are probably closing in on how much it can do. The tooling will improve, but it's a one-up for developers, actually.
Thank you.
Talking about Lava specifically, okay, like the code it generates is not great. How about following a style guide? Can it follow a style guide consistently for the UI UX part?
You mean more like a design system, UI style guide, or code?
Yeah,
the design system. Lovable is quite good at these. I think that's one of the strong sides of the platform, with all of the downsides it has, is these UI elements and things like that. A lot of you see, most of them use like a short CN library with some design. But what you can do is you can start with, if you have your design system defined in Figma or something else, or created in another tool, if you can export example components, even example file, code snippets, all of that, and put them in your agent.md file or whatever, they're pretty good at following those. We even migrated from design system that was kind of vibed at the beginning to an actual design system, and refactored a lot of things following like an export from Figma. It was actually done through like an MCP server and asked to write it down in a structured way, but it worked quite well. So my experience is that it follows that. And for the code things, you should put things, in my opinion, to kind of expand a little bit about code structure and approaches that you want to use, or patterns, and not care about linting issues too much, because a lot of those you can automatically resolve. Just run your lint fix on your whole code base and do a huge commit or whatever. And then for like smaller things, it's maybe, if you don't firsthand interact with code as much, you can maybe have a bit more give in the, not to say quality, but a little bit on the structure. But this is a very touchy subject. Yeah, you will see. Okay, I hope I answered. There was a question there for a while.
Yeah, I wanted to ask about models. I agree with your idea that in the long run it won't matter that much because of the tooling, but right now, in my experience, it matters a lot which model you are actually using. For example, if I want to do analysis, I use GPT-5 for code changes. Claude is quite good at surgical changes, actually. How do you select models?
I also kind of like your response you gave yourself. I kind of do exactly the same a little bit. My first preference is Claude, but what I've learned over time is that you have to think of these models as just a different people or different personalities. You will end up learning how to prompt this exact model over time. So for example, Claude is more STEM, it's more technical, more kind of structured things, right? For more ideation, you might use something a bit different. And I also have specific tasks that I would give to the one or the other. For the code editing, it's Claude 90% of the time. I might, when I don't like the results, let's say the third time around, when I ask to give me options, I might switch and try something else. So that's a good parallel decision as well.
Sorry, Tommy, but you can come ask question in person. He will be here next 20 minutes.
Yeah.
We have to finish now and go into break. Thank you very much.
I'll be in the kitchen.
He'll be